Hello everyone. In this lecture, we want to find out the distance between a point and a given line. So we have a line here whose equation is y equals 2x plus 3. It is very clear what the slope is, that is 2, what the y-intercept is, that is 3. And we have a point which is not on this line, obviously. It is at a distance of d units from the line. And when we say distance in geometry, it means perpendicular distance. Coordinates of the point is 6, 5. We just want to find the distance between the point and the line. First of all, I explain the strategy that we're going to use, the reasoning. So what we're going to do, we are going to write the equation of a line that is passing through point A and it's perpendicular to this given line. So something like this. So it's going to be a line, okay, which is perpendicular to the given line. Okay, we're going to write the equation of such perpendicular line, and then we are going to find the point of intersection of these two lines, which is this point right there. I call this point H. Okay, and then the moment that we have the coordinates of point H, because we already have coordinates of point A, we can use the famous length of a line segment or distance formula, and we can actually find the exact distance between point A up to the given line or the foot of the perpendicular. So that's the logic that we are going to follow. So my goal here is to write the equation of the red line, first of all. But what would the equation look like? I think the equation is y equals mx plus b. End of the day, that's the equation of any line, let alone the red line, which is perpendicular to the given line. But the thing is that if these two lines are perpendicular, the slopes must be negative reciprocals. We know this from before. So we said that the slope of the given line is 2, right? So what is negative reciprocal of this slope? Obviously, it's negative 1/2. So that means that the slope of the red line must be negative 1/2 times x plus b. All right? Why? Because the red line is perpendicular to the given line. So if the slope of the given line is 2, then the slope of the perpendicular line must be negative reciprocal of 2, which is negative 1/2. So this red line has this equation, negative 1/2 x plus b equals y. But what is b? I don't know yet. We don't know yet. We have to find the value of b. So in order to find the value of b, we're going to use the fact that the red line passes through the point A. Therefore, the coordinates of point A should satisfy the equation of the red line. So instead of x, I plug in 6. Instead of y, I plug in 5. These are the x and y coordinates of point A. And using the fact that coordinates of point A must satisfy the equation of the red line, and left side must equal right side, we are going to calculate the value of b. So 5 plus 3 equals b, because 6 times negative 1/2 is negative 3. So b would be equal to 8. Okay, so we're going to substitute back. So y equals negative 1/2 x plus 8. So the puzzle is partially solved. The equation of the red line is found. So this is the equation of the line that is perpendicular to the given line and it passes through the given point A. Now, next part of the question, second step, is to find the point of intersection. So I'm going to construct a system of equations. So the first line is 2x plus 3 equals y. The other one is negative 1/2 x plus 8. And now I'm trying to find the point of intersection of these two lines. So I'm going to say y is equal to y. This is called comparison method, or you can call it substitution if you want. So 2x plus 3 equals negative 1/2 x plus 8. That means 2x plus 1/2 x equals 8 minus 3, which is 5. And here on the left side, we have 5 over 2x multiply both sides by 2, you get 10, and guess what? X is equal to 2. So x equals 2 is the x coordinate of point H, which is the point of intersection of the two lines. To find the y coordinate, we are going to substitute in one of the two equations. So 2 times 2 plus 3, that's 7. Y equals 7. So that means that point H has coordinates of 2, 7. So H has coordinates of 2, 7. Okay, so that was step 2 of the problem, big step 2. That was step 1. This was step 2, finding the coordinates of point H. And now, in step 3, we are going to use the length of a line segment or distance formula. I'm going to find the distance between point A and point H. So AH, or so-called distance we are looking for, it's going to be x of A minus x of H squared plus y of A minus y of H squared. So substitute numbers. X of A is 6. X of H, we just got it. It was 2. Okay. And then y of A is 5. Y of H is 7. We just got it. And this is going to be 16. And that's going to be 4. So that would be square root of 20, in other words. Now, 20 can be broken down as 4 times 5, clearly. So this would be square root of 4 times square root of 5, which is 2 square root of 5 units. Okay, so the distance between point A and the line is 2 square root of 5 units, and this is called exact value, of course. Now, if you want to find the approximate answer, correct to one decimal place, you can multiply root 5 by 2 using a calculator. It's going to be about 4.5 units. So 4.5 units. So in this question, we wanted to find the distance between a point and a line, and we, of course, found it using this coordinate geometry strategy that we picked and we followed, and we used our knowledge of coordinate geometry, knowledge of formulas we have studied in the past, either in this grade or earlier other grades before, and putting all these information together, we could find the distance. Now, there is, believe it or not, I don't need to add this part, but it doesn't harm. There is a formula, believe it or not, that you can use to find the distance in one shot without doing all this work. So if you have a line, okay, just like we did have a line, ax plus by plus c equals 0 is the equation of this line in standard form. And if you have a point outside, let's say point P, with coordinates of x1 and y1, so that distance d can be found by some sort of magic formula. Now, the magic formula is this. The denominator is square root of a squared plus b squared, and the numerator is the absolute value of a times x1 plus b times y1 plus c. Absolute value of any number is its positive value, and the symbol for absolute value of any number is those vertical lines that we put. Now, because distance cannot be negative, that's why we put the absolute value in the numerator to make sure that we do not end up with a negative answer. Now, you may say, okay, how can we use this magical formula in one shot and very quickly get the same answer that it took forever to find it? So let's try to see if this formula, magical formula, works or not. So I'm going to say distance equals. Now, first of all, I have to write the equation in standard form. So this would be 2x minus y plus 3 equals 0. So a, b, c are 2, negative 1, and 3. So it would be a, which is 2, times x sub 1, which is the x coordinate point A, so that's 6, plus b, which is negative 1, times y coordinate of the given point A, which is y sub 1, that's 5, and then plus c, which is 3, and we take the absolute value of the numerator. So if we end up with a negative answer in the numerator, we're going to consider the positive value of that number. And the denominator is square root of a squared plus b squared, so that's 2 squared plus negative 1 squared. So that is the final answer. So you don't know, I don't know, but I claim that this answer, whatever it is, it has to be perfectly matching with 2 times root 5 or 4.5. And I got this answer in one shot instead of doing the whole work as you saw before. So let's try to see what we get. 2 times 6 is 12. So 12 minus 5 is how much? 12 minus 5 is 7. 7 plus 3 is 10. So the numerator is 10. The denominator is 4 plus 1 is 5. So square root of 5. So we are going to multiply the top and the bottom by square root of 5. This is called rationalizing the denominator. So multiply the numerator by root 5 and multiply the denominator by root 5. So basically, we're multiplying by 1, which is okay. Now, root 5 times root 5 in the bottom is just root 25, which is 5, and 10 over 5 is 2. So the answer is 2 square root of 5. And we can say bingo. That's exactly the same answer we got from before. So this is a shortcut formula, famous in mathematics, maybe in your textbook, maybe not. You may want to know that maybe in future you participate in a math contest or something, and these formulas become handy, and you quickly find the distance between any point you want and any given line instead of doing all the work systematically as we did. Okay, thank you for your attention.